Welcome to the DIY Honda Garage channel. The DTC P2118 indicates a problem with the throttle actuator's current range or performance in the Honda Civic models from 2011 to 2015. The throttle actuator plays a crucial role in controlling the amount of air entering the engine, which is essential for proper combustion and engine operation. It is typically located in the throttle body, integrated with the engine's air intake system. When this diagnostic trouble code appears, it often signifies an electrical issue or malfunction within the throttle actuator itself, potentially leading to inconsistent engine performance or response. Before starting the troubleshooting process, it is important to record any freeze data or onboard snapshots to reference the vehicle's state at the time the error code was triggered. This data can provide critical insight into what may have caused the issue and should be considered during the diagnostic evaluation. Also, reviewing general troubleshooting information can offer guidance on the specific steps to take to resolve issues related to this error code effectively. The throttle actuator is integral to the vehicle's throttle body, which controls the airflow into the engine. By modulating this incoming air, it directly influences engine performance, efficiency, and responsiveness. When a malfunction occurs, it can cause various performance issues such as hesitation during acceleration or a check engine light illumination. The throttle body is usually positioned between the air intake and the engine's intake manifold. This component requires precise electronic control, and any fault in the throttle actuator's current range or performance may trigger the P2118 code. Understanding the location and function of the throttle actuator is essential because diagnosing issues in this area often necessitates examining both the actuator itself and its associated wiring and connectors. When troubleshooting DTC P2118, various potential causes must be considered. The first possible cause is open or short circuits in the wire harness connected to the throttle actuator. Such wiring problems can lead to insufficient current reaching the actuator, resulting in performance issues. Secondly, defective wiring or poor connections at the throttle body or engine control module, ECM, can also create complications. A common scenario is loose terminals or corrosion at the connectors that can interrupt the electrical flow. Lastly, there may be internal faults within the throttle body itself. Throttle bodies can wear out over time or become contaminated, leading to poor performance and the triggering of this diagnostic trouble code. Checking these components thoroughly can help determine the root cause of the problem. Common symptoms associated with DTC P2118 include the illumination of the check engine light, CEL, which alerts the driver to a potential engine management issue. Drivers may also experience poor acceleration when attempting to increase speed, leading to concerns about the vehicle's performance in critical situations. Moreover, intermittent engine stalling may occur, particularly during idle or low-speed maneuvers. It's essential to note that the symptoms may not be constant, often presenting themselves sporadically due to the nature of electrical faults. Observing these symptoms is crucial for a proper diagnosis, as they provide insight into how the vehicle is reacting to throttle actuator issues, which can assist technicians in identifying the specific area of concern during the troubleshooting process. In the first step of troubleshooting for DTC P2118, begin by turning the ignition switch to the on-to position without starting the engine. This activates the vehicle's electrical systems, allowing for diagnostic access. Next, clear any diagnostic trouble codes using the HDS or Honda Diagnostic System, which clears previously logged codes in the ECM for a fresh start. After clearing the codes, slowly press the accelerator pedal all the way to the floor. This action is critical, as it allows the system to read the full range of throttle position, providing essential data to the HDS. After performing these steps, check again for pending or confirmed DTCs using the HDS. If DTC P2118 appears again, it indicates that the failure has replicated itself under these conditions, and you should proceed to the next troubleshooting step. However, if no DTCs are indicated, there may be intermittent issues or poor connections that need to be further examined. Step 2 requires turning the ignition switch to the lock 0 position to power down the vehicle's systems completely. After this, use the HDS to jump the SCS service check connector line, which is a temporary connection meant for diagnostic purposes. Following this, disconnect both the ECM connector C, which consists of 49 pins, and the throttle body's 6P connector. This allows for direct testing of the wiring without interference from other components. The next action is to check for continuity between specified test points in the wiring. Ensure continuity exists between the gray wire at the ECM connector C, pin number 14, and the gray wire at the throttle body 6P connector, pin number 3. If continuity is present, this confirms that the SG3 wire is functioning properly, necessitating a move to step 3. However, if testing shows no continuity, this indicates an open circuit issue, requiring repair of the SG3 wire before rechecking the system. In this step, continuity testing is critical to check for short circuits between MTR1 and MTR2 wires. Begin by confirming the ignition is in the lock 0 position again, with both the ECM connector C and throttle body 6P connector disconnected. Utilize the HDS to confirm continuity between test points 1, pink wire at the throttle body 6P connector number 1, and 2, green wire at the throttle body 6P connector number 2. If the test reveals continuity, this indicates a short exists in the MTR1 and MTR2 wires between the throttle body and the ECM. Consequently, you'll need to repair this wiring fault adequately. If there is no continuity detected, proceed to the next troubleshooting step. This process is crucial to isolate any wiring faults that may be contributing to the DTC P2118 and to restore the integrity of the throttle actuator signal. For step 4, again ensure the ignition is in the lock 0 position with the appropriate connectors disconnected. This step involves testing for continuity between the MTR1 and MTR2 wires and body ground. Connect test probes to check the green wire at the throttle body 6P connector number 2 to the vehicle's body ground, and then the pink wire at the throttle body 6P connector number 1 to the body ground as well. If continuity is found, it signifies that there is likely a short to ground in either the MTR1 or MTR2 wires, which could disrupt normal throttle actuator functionality. In such a case, repairs are necessary to rectify this short. Conversely, if no continuity is detected, it indicates that the MTR wires are intact, leading you to the next step in the troubleshooting procedure. Thorough testing ensures that any electrical faults related to grounding are appropriately addressed for successful throttle actuator operation. Step 5 focuses on assessing the throttle body's internal circuitry for short issues. To execute this test, ensure the ignition is still in the lock position and the connectors are disconnected. It is essential to measure the resistance between designated test points on the throttle body 6P connector. Specifically, check between test points where MTR1 and MTR2 connect at the throttle body. The expected resistance should be approximately 1.2 to 1.0 kiloohms, indicating the integrity of the throttle body's internal circuits. If the measured resistance falls within this acceptable range, advance to the next troubleshooting step. However, if the resistance deviates from this value, it infers that the throttle body may have internal faults, necessitating its replacement for proper function and performance, ensuring that the DTC P2118 is resolved. In the sixth step, you will again measure resistance to check for shorts to ground within the throttle body. With the ignition in the lock 0 position and all connectors still disconnected, check the resistance between both test points for NTR1 and NTR2 at the throttle body side. It is crucial to connect one probe to the green wire at the throttle body 6P connector number 2 and the other to body ground. And similarly for the pink wire at the throttle body 6P connector number 1. If continuity exists, it suggests a short to ground and indicates that the throttle body indeed requires replacement. On the other hand, if no continuity is found, then the internal circuitry of the throttle body is functioning adequately, allowing you to proceed by updating the ECM engine control module software if it is not current, or substituting a known good ECM for further diagnostics. This ensures that all possible faults leading to DTC P2118 are effectively investigated and resolved. After addressing all issues related to the DTC P2118, it is time for final repair verification. Begin by turning the ignition switch to the lock 0 position. Then reconnect all previously disconnected connectors to ensure full circuit integrity. Once all connections are securely in place, turn the ignition switch back to the on 2 position to power the vehicle's systems for testing. Reset the ECM using the HDS to clear any old, stored codes and prepare the system for a fresh start. Following the reset, it is crucial to perform the ECM idle learn procedure, which allows the ECM to calibrate its understanding of the current throttle position and optimize performance. Finally, press the accelerator pedal slowly to the floor and check for any pending or confirmed DTCs using the HDS. If DTC P2118 appears again, further inspection is necessary. Otherwise, troubleshooting is successfully complete and the vehicle should operate normally. Preventive maintenance is essential in avoiding future occurrences of DTC P2118 and ensuring long-term reliability of the throttle actuator system. One of the most effective practices is to conduct regular checks of all wiring associated with the throttle actuator and ECU. Inspect wiring for signs of wear, corrosion, or loose connections that may develop over time. Additionally, it's a good practice to clean the throttle body periodically to prevent debris accumulation and ensure smooth operation of electronic components. Built-up residues can inhibit the throttle position sensor's performance and lead to issues. Updating the ECM software is also vital, as manufacturers may release patches or improvements that enhance vehicle performance or address known issues. By adhering to these preventive measures, you can help maintain the health of your vehicle's engine management system and avert similar diagnostic issues in the future. In conclusion, effectively diagnosing and resolving DTC P2118, which pertains to throttle actuator current range or performance issues, requires thorough understanding and systematic troubleshooting. Recognizing the symptoms is the first step, followed by diligent adherence to prescribed troubleshooting actions to pinpoint underlying electrical issues. Each step is critical, whether it involves checking for open circuits, verifying wire continuity, or assessing the throttle body's functional integrity. Lastly, preventive measures like regular maintenance and software updates are fundamental in sustaining the health of the engine management system. By following these guidelines, vehicle owners and technicians alike can address and resolve DTC P2118 efficiently, ensuring optimal engine performance and reliable vehicle operation into the future. Please like and subscribe to the channel. See you next time.